HIPERWIND set out to achieve a significant reduction in the levelized cost of energy by understanding how to deal with uncertainties into the wind turbine design modeling chain. So there we wanted to consider how to quantify, how to identify the different uncertainties, starting from environmental conditions through loads and also reliability assessment of wind turbines. And use all this information to see if we can actually reduce the material use by knowing better what is the performance of our models and where we need to focus on reducing uncertainty, and as a result reduce the material use and ultimately reduce the cost of energy. So we worked on a particular use case, which is an existing offshore wind farm called Teesside off the coast of England, owned by one of the partners, EDF. And we used data and models which were intended for use on this wind farm in order to set our use case, quantify all the uncertainties associated with the design of the turbines that are placed in this wind farm, and see if, based on our, let's say, improved knowledge after the project, if we can reduce the cost of energy coming out of the wind farm if we were to build it again. The primary result from HIPERWIND, first and foremost, is that we have learned how to incorporate uncertainties into the design process. And this in itself is an achievement because it takes an order of magnitude more effort to include uncertainties, because you need to look at statistics, probabilities, instead of single values, which leads to more effort. You need to deal with bigger data sets, more numbers, more repetitions of everything. Also, you instead of just making assumptions, you need to quantify these uncertainties. And all this has been an effort in terms of scientific work and numerical simulations work. And all this together, just learning how to make this in an efficient way and demonstrating that it can be done, it's a very useful outcome, which has been beneficial for all the partners to improve their capabilities. Then I think also some specific learnings, for example, the importance of actually looking at integrated design. So doing the design, all the parts of the wind turbine together as a system, rather than, for example, looking at the rotor and the foundation separately, which we actually expect that this may be one of the reasons why we see such a big difference between the, let's say, the original designs we have in our use case and the improved designs we obtain based on our project efforts. It could also partly due to considering uncertainties, but also due to being able to take everything into account together. As an important factor is the effect of average cost of capital on the levelized cost of energy. For example, we did try to estimate exactly how much our design improvements would improve the cost of energy. And it turns out that this estimate is uncertain in itself because we don't know what is the average cost of capital. If the average cost of capital is like it's nowadays, then design improvements could reduce the cost of energy by 10%. If the average cost of capital is as high as it has been 10 years ago, then our design improvements would have only influenced 5% of the total cost of energy, because the cost of energy in itself would have been much higher due to the higher capital costs. I believe that we can show that there is a way to reduce the amount of material used into the turbines. So reducing the cost of materials leads to reduced capital expenditure, which forms maybe about 30% of the total levelized cost of energy. And because of that, we do see a reduction in the levelized cost of energy by simply improving the design. Other parts of the total cost of energy reduction is because of improving the operation and maintenance process, where through optimization we could see when it's more beneficial to carry out maintenance and how to shorten these periods and how to optimize the entire process. Also by finding out what are the appropriate times to do maintenance, which, for example, we would like to do it at times when the energy prices are low so that you don't lose revenue while doing maintenance. This cost reduction, or in general the science produced by HIPERWIND, will benefit the entire industry. Of course, I think the partners into the project are lucky, or they're privileged, because they have been part of this process for 3.5 years and they have obtained many new capabilities that I hope that they will use very soon in their future research and their business. While, of course, the project outcomes are to a large extent public. We have many scientific papers, publications, but of course we also have a number of software tools that are open access and available to the entire community, which is indeed with the intention to make sure that the impact is as broad as possible. So we are inviting all industry or other academic organizations to make use of these results as much as they would like to.